Cool. You ready?
Hello, everyone. My name is Tyler Zamsky. I'm part of the medical mainframe database team. So this is going to be a little bit of an update from our presentation from a few weeks ago, but also as a bit of a summary for those of you that are joining us in summer 2. So the goal of our project was to see if it was viable to build a database of medical information inside a mainframe. Now, what does that mean? So to deconstruct that, there's 3 key components that we're going to talk about. The data itself, the database, and then the mainframe aspect of it. So to talk about the medical data itself, I'm going to pass it over to Katie.
I'm Katie Mooney. We took our data from CDC.gov. It's the National Health Survey data set, and it's a CSV format. And so it's about, per one data set, it's about 45 million pieces of data. We use 6 data sets. It's household, which is broken into family. And from family, it's broken into person, which is broken into injury, poisoning, adult, and child. A sample of one data set is the person CSV has about 600 columns, and each column has a question, a survey question, and 78,000 records of individuals and their responses to the data set, to survey questions, which is about 45 million pieces of data. That's just one data. So, the person that makes it all happen is Mike.
I'm Mike Menendez, and I work on the database architecture aspect of that. Now, obviously, we need a special software to work with such large amounts of data. I use Irwin Data Modeler, and so the process begins, of course, with ETL mapping, which is extract, transform, load. That's essentially formatting all the digits that you saw earlier into actual referential data, which is readable by the user. In addition, we then had to make this beautiful graph, which then showed the actual hierarchy and the ability to navigate these data sets within one another, person from family, family from household, et cetera, et cetera. What this allows us to do is actually establish an analytical capability where you're then able to look for a certain entry within an entity and find exactly the data that you're looking for and that you're trying to make queries of. Now, of course, to house all of this and all the data that Katie talked about, we need an incredible piece of hardware, Mainframe, which Andy.
Hi, I'm Andy Gonzalez, and I'm the hardware guy. So in order to make all of this actually happen in the real world, we need something called a mainframe. That's a mainframe, one of the most powerful computers commercially available. We don't have one. Thank you,
Yes.
Louis. And so, with that, we actually have access to one in Dallas, Texas, that's actually used to teach people how to use the system. So here's kind of a peek. This is a TN3270 interface in which we use to actually talk with the machine. These pieces of equipment are focus built to be efficient, lightning fast, and basically the fastest thing on the planet. On top of that, when we're dealing with the data sets, we don't exactly have a GUI system to just drop it like a Dropbox. We actually have to use something called file transfer protocol. So here's what basically my day is like. We log in, and then I have to go through the entire process of making sure that our connection is secure, so whatever data that we're dealing with is transferred between here and Dallas. On top of that, this is the interface that everyone, when they use a mainframe, is like. It's called ISPF. And so with ISPF, we are able to access our data sets. And these are our programs, our files that are specifically to our share of the data. And then on top of that, we need to start sending stuff. So we send these SITs, 12, 15, and 32 gigabyte files, and that's why IT hates us, up to Dallas. And then from there, we're able to use our own little programs that we write in order to organize that data in a way that the computer on their end actually understands. The mainframe speaks a different language than most of the computers that we use today because they are built to be efficient, not to be user-friendly. We then, that's more code and code. We then use something called DB2. It's a database management module within all mainframes. It's one of the most powerful tools within mainframes. Every single time you've used your credit card, debit card, every single time you've ordered something on Amazon, every single time your information gets looked up by a police officer who stops you, it's through something like this. All of that data goes through some machine like this somewhere in the world. And so we then use that in order to start putting our own little commands, SQL arguments, and trying to build tables. Everything that Mike was showing you, this is how it looks like on the technical side. It's all just lines and lines of arguments. And then at the end of it, we get a successful drop, and that was the lookup table that was at the bottom of the diagram that we showed earlier, and that's when it successfully shows and is viably used within the DB2 mainframe system. Trust me, this is actually really cool. I just, there's not much you could do with their GUI. Now, what else that we can actually do with this, or what we're going to do moving forward, we have Tyler.
Sure. So just to quickly summarize what we've been up to. So we've built our first proof of concept model, right? So we have a table up on the database that Mike has modeled. It is populated with the cleaned data that we've run through our assembly code. And now we are moving into the final step of our project, which is transferring the rest of the data up there, creating tables for it, and then finally using SQL queries to analyze trends, correlations, patterns, anything that might be of interest within the data itself. And then finally, building and establishing a system for users to query the database on their own. And that's it. Thank you.
Question?